Hello students, in this video we use the formal definition of a limit to show that a quadratic function has a limit that exists. Let's show that the limit as x approaches 3 of x squared is what we expect to be equal to 9. And so let's use the approach of saying what do we want to have happen and use that to craft our delta. What we want, I want x squared minus 9, my function minus my limit, to be less than epsilon. This, of course, is what? Is x plus 3 times x minus 3. I want that to be less than epsilon. And remember that as x goes to 3, the x minus 3 is less than delta. So I'm going to have an x plus 3. And then over here I have a delta less than epsilon. The problem now is that I can't really estimate this x plus 3 in terms of delta because it's not close. However, let's suppose temporarily that delta was equal to 1. Well, if delta was equal to 1, then our x minus 3 less than delta would be equal to 1. And what would that say? That would say that negative 1 is less than x minus 3 is less than 1. And that would say what's the absolute biggest that x can be? Well, over here it's 2 less than x less than 4. So the absolute biggest that x can be in this range is 4, right? So over here, if delta was equal to 1, if delta was 1, then if delta is 1 or smaller, then absolute value of x is less than or equal to 4, and therefore, thus, x plus what? X plus 3, by the triangle inequality, will be less than absolute value of x plus 3 will be less than what? Will be less than 7, okay? So if delta was less than 1, this would be a 1 over here. That would be a 7 delta, and that would say that delta should be chosen to be epsilon over 7. Well, now I have two demands on delta. I'd like delta to be epsilon over 7, but also less than 1. So I can make that happen by choosing delta to be the smaller of those two numbers. So now we choose, so let epsilon be greater than 0, and choose delta to be the minimum of 1 and epsilon over 7. Okay? Then this condition will be true. This condition will be true, and then this will be a 7 delta. So now let's continue with our proof. Suppose that 0 is less than absolute value x less than 0 less than absolute value x minus 3 less than this delta. Then we automatically know that since x minus 3 is less than, it's certainly less than 1, then absolute value of x plus 3 is less than or equal to 7. Great. Now, let's estimate x squared minus 9. That's our function minus our limit. That's x plus 3 times x minus 3. X plus 3 is less than or equal to 7 by our condition over here in absolute value times x minus 3. But x minus 3 itself is less than delta, so this is strictly less than 7 delta. But delta is definitely less than epsilon over 7, so this is less than or equal to 7 times epsilon over 7. Which is equal to epsilon. So I've shown my function minus my limit is less than epsilon if x minus 3 in absolute value is less than delta, and that formally proves that the limit exists. Thank you very much.